Today, I'll be talking about our State Highway 7 project in Leon County. I'm going to go pretty fast through here, so we'll have time at the end for questions. Um, if you don't understand something I'm saying, just raise your hand, ask a question, I'll repeat it. Um, the overview of the project, it's a 1 mile section. We've decided to start off slow and do a sort of a test section on with the foamed asphalt. It's a 1 mile section from FM 39 to 1 mile west. It's a $1.4 million project awarded to AL Helmkamp. Construction started in 2015, this year in August, and this is an extremely heavy truck traffic route. It has a lot of base hauling activity, and it's an energy sector roadway. So this is the existing condition of the roadway. You can see there's heavy flushing. We've had to make multiple patches. The maintenance crews are out there constantly, every day, patching holes for the entirety of State Highway 7 through our district. There's some more potholes and some more failures we had. Here's some of the data we used for design. The 20.1% trucks is probably extremely low. I'd say there's at least 40 to 50% trucks. That number doesn't do any kind of justice for it. If you go out there, the queue of trucks, it was probably almost 3 to 1 trucks to vehicular traffic. In the design of this, I'll go ahead and say that Stephen Sebesta and Tom Scullion with TTI did a corridor analysis for the entirety of State Highway 7. So when I say we, I'm meaning TTI and TxDOT with this design. It's absolutely critical to go out there and get a lot of testing prior to construction and during the design process. You want to have a good idea of what your asphalt content is going to be for the foamed asphalt, so you can get a good estimate for the contractor, so they're not playing a guessing game. We ran GPR testing, decided that this location here was probably indicative of what was out there on the project. You can see we have a base overlay of hot mix asphalt and then just iron ore base with a hot mix overlay over the top. This right here is where our section lies, but in reality we had pretty much every one of these sections in that 1 mile section when we actually got out there on the project, and there'll be some pictures later on to show that. This is the design of the project. We went with 10 inches of foamed asphalt treatment, and the 4 inches of base is just what we have remaining. We did not go with any kind of cement in the design. The testing in the lab showed that 2.4% foamed asphalt met the minimum by a significant amount, and it didn't increase very much with that 1% cement. And I'll discuss later why that was probably a misstep on our part. During the construction, you need to make sure during the pre-construction meeting you go over the specifications very well with the contractor, that they're knowledgeable about the specifications and their requirements, that you know that the people that are going to be out there inspecting the project know what needs to be done prior to beginning construction. You want to make sure you have the proper equipment for the job. Our equipment, the mixer it traveled approximately 17 feet per minute, and the drum ran at about 153 RPMs. You want to make sure that you're getting the equipment out there to get full depth compaction for your treated layer. You can check that by using your nuclear density gauge to make sure you're getting your optimum moisture and max density, and run a DCP on the material to make sure you're getting consistent compaction throughout that layer thickness. This is a picture of the test section we did prior to construction. And then this is the testing to make sure that the foamed asphalt is actually foaming in the mixer. And you want to make sure that the half-life is, it meets the foam asphalt meets the half-life of what's in the specification. Here's a picture of the train running with the mixer. Right here is the asphalt transport, and then back behind, you can't see it, but the water truck is connected to the right here. The water truck is connected to the mixer as well. This is a picture directly after the mixer goes through. You can see it's very consistent and doesn't look like true black base. It's only got 2.4% asphalt in the mix. So it's not going to be a true coating of the entire base. It's just going to be, it's going to look almost like it's just regular cement treated base in some aspects. This is we used a 20 ton roller on the project since we were compacting 10 inches. They made 5 complete passes on the material. It met density after those 5 passes, and without any kind of finishing rolling or anything like that, it was meeting density pretty quickly with that 20 ton roller. And then the rest of the production equipment is the typical blade for striking off the pad foot markings, running behind with a steel wheel, and then pneumatic to set or to seat any of the loose material. You want to make sure you get your fog seal on the project at least an hour before opening to traffic, and then get it sanded just to have it give it a little bit time to set before opening up to full traffic. There's a picture of our smooth ride of the roadway, and then the truck traffic running directly on it with, in this section, little or no problems. We did have some issues during construction, which that's the good thing, and we don't learn anything if everything goes perfectly, which everything did not go perfectly here. You can see, I mean, the material changes out there were so drastic. You had the white material here that looked like a solid flex base. Then you had the darker gray and then red material here, and then all of a sudden you go to a totally different flex base than what's right here. And it goes like this all the way down the length of the roadway. So that caused a few problems. We also had a lot of moisture at the very beginning. We checked the moisture in the first 500 feet. Everything looked good. Densities were good. Then we go just 600 feet down the roadway, and we start seeing that the water content is 6% above moisture. It's spongy. It's like, I mean, you can stand on it and you can move, and you drop about 1.5 to 2 inches with just standing and walking over the compacted material. So after that, we just had them turn off the water. They didn't add any additional water, and then after that transport was finished is where we figured out there was a problem. After that, we had little or no problems with moisture content. So you need to make sure you're pretty diligent about checking your moistures steadily on that, especially that first day of production, to make sure that you're not going to have any of the problems we saw. This is a pretty good picture. It shows that we had not just the moisture that was in you can see this before the connection here was spewing out a lot of water, but I mean, it's rutting way before that water was getting down on it. It's just that this didn't help anything either. So having good equipment is critical as well. This is actually going up to the top of a hill. So we have, I mean, Bryan District's known for having really bad soils and bad conditions, but I mean, we've got a heavy moisture problem at the top of a hill where no moisture problem should be. This is showing the rutting after the construction, and you can see, I think there was about a 1/2 inch to 1 inch rutting directly after, with just a few trucks, the construction crews running over it, and this was not open to live traffic yet. This is a picture showing the good DCP results. You can see the individual ones are pretty consistent. What you don't want to see is that, something like this coming out and then a bowl coming out here where it's a weaker section down at the bottom of your layer of foamed asphalt. So we ran DCP on the places where we had moisture problems, and you can see that the top, about 5 inches, was where we were having the major moisture issues. So what we had to do is come back and cement treat full depth with, I think we went 2% cement out in the field. And then down here, this green and this green are in the exact same station, just at the center line and the outside wheel path here. And you can see a significant amount of values where one day after production, there shouldn't be that much difference between 8 feet. So we found these isolated locations in the outside wheel path and cement treated those as well. This right here, we had a major problem with the water truck, or where they were disconnecting the water truck from the mixer when they would turn around. And this is the only place we saw this type of failure, is right where they were ending one transport and starting another, or turning around to go to the next, the opposite direction of traffic. These were the isolated outside wheel path failures, and you can see the cement truck dropping the cement there and getting ready to mix it in. I just wanted to show this, that right here is the grouping of the good locations of our test, which you see the vast majority of our testing was really consistent. It was down here where we had all the moisture problems. We started having a lot of failures. So moisture content is absolutely critical in this foamed asphalt. These are the Modulus values. Down here on the day of production, we got somewhere around an average of 35 KSI, which is not what we wanted to see. We actually designed the project for 300 KSI, and due to the variability of material, the moisture, a lot of that didn't happen. It didn't stiffen up like we thought it would. But then just 2 weeks after production, you see it doubles or triples almost. And then at 1 month, this section here, this first 0.3 of a mile or so, is where we actually had the cement treatment of the full width. And you can see that it reached, easily 300 with that cement added. But even without that, it stiffened up quite a bit to about 150 KSI for the untreated, or the treated foamed asphalt without cement. These are the deflections, and we use the manual back calculation program to figure out what the desired deflections were. And you can see the red, we had quite a bit of deflections the first day of production, and then it decreased significantly 2 weeks later, and then now within a month, just last week, we got down to where our deflections were expected to be. Like I talked about before, the moisture was a problem. Our initial design modulus at 300 KSI wasn't met. We really only got about 150 KSI, and this is actually a picture of Tom, so he's running a DCP. He actually does go out there and test every once in a while. Lessons learned. The testing before beginning construction is also very important to make sure that the contractors go out there and get a moisture sample prior to their construction, because we had a month solid of rain and now 3 months of no rain. So 6 months before that, there's no telling what that moisture actually is at that moment. So you need to make sure the contractor tests that before they start. Prevent the water spills that connect the disconnection points. Quality control testing is absolutely critical and necessary. May want to require the contractor have a contract lab available in the next version of the spec. Addition of 1% cement will be necessary for our district here in Bryan, because our variability in the soils and the moisture content is just too much to not have that extra insurance against running into these type of problems. You want to have experienced inspectors and engineers on the project. We were lucky we had an engineer and an EIT, and both were really well versed in the specifications and knew how much to test, and they were right behind it, checking them as they needed. Make sure you have the asphalt and the moisture corrections for your gauge. Ours varied by about 3% higher than what the actual moisture content was, based on the hydrocarbons in the asphalt and the cement. So you may want to include items for full depth repairs. If you see there's some really bad areas that are rutting and breaking up, don't just go through with the foamed asphalt treatment. You need to address those before the treatment, the actual foamed asphalt treatment occurs. We may want to include lime or fly ash for excessively wet areas if you have any of those low-lying areas, and consider a HMA surface for a better final ride. Our ride is pretty rough right now, and we actually are going to go with a hot mix overlay to address that, as well as the lower modulus values than what we had for the design. Wouldn't consider it a touchdown on this project, more of a field goal. We'll need to go back and rethink our methods, which we've already kind of done that. We know that the cement is really what we need to add, and I think that would address most of the problems with the modulus values that we saw. We do have projects planned for 2016, this fiscal year, and it's going to be from State Highway 7 from I-45 all the way to somewhere right in this location. It looks like a checkerboard or a patchwork quilt out there. with the maintenance crews having to go out there, and they literally are going out daily to fix those. So those will be letting this fiscal year, and I believe it's either 2 or 3 projects. And those are the kids. They are all going to be Aggies because they know they can go to any university they want to, but if mom and dad are going to pay for it, it has to say Texas A&M on the check. Oh. Yeah.
All right, man. That was a great job, Steven. Thanks. Very good. I appreciate you all coming in. I appreciate the opportunity to come out here to present. Thank you, Mr. Bostic, for moderating. Thank you very much, Dave and Andrew, for inviting me to come out. My presentation is going to be on a fairly similar process about FDR, but in our case, I'm looking at emulsion-treated base. I should look that one out. Just to give you an idea of what it is, it's a full-depth reclamation process, a little bit different than what Steve was talking about, though. Instead of actually trying to throw in some hot PG oil, what we would be using in this potential process is just actually emulsion. There's no need to throw in any additional water because there's already water in the emulsion, or there could already be some water already existing in the existing base. So just to give you an idea of what the process is you got a reclaimer that hooks up to a distributor that's going to start to meter in the emulsion. And that's kind of what it looks like in the actual reclaimer. It comes out, it's automatically mixing up the existing material that you have out on the road, try and get a uniform set. Then you want to come back in, similar process, hit it with pad foot, try and get some initial compaction down. Bring in a blade, spread it out, get a nice uniform level surface. Might hit with the pneumatic, come back in with a steel wool behind it, try and get that final compaction. Just to give you the idea of the process. So where is it that we should actually be looking to use this? And for us, we're actually in a very similar situation to what Stephen was talking about, where we have a lot of roads in the energy sector that are just not structurally sufficient. And we end up running into a couple of boundary conditions that we can't get around. Number one is phasing of the job. It's very difficult because a lot of these roads are very rural, so we don't have a lot of right-of-way. We can't go out there and build a detour to go around the section we're going to work on because that's just going to drive the cost through the roof. If we go out there and we put 24-hour traffic control to try and do some type of rehabilitation process, that's going to throw the price through the roof. So FDR starts to become more of an option where we can try and do something immediately and have it open to traffic at the end of the day. Some of the other boundary conditions that we keep running into is we can't raise the structure either. A lot of the sections that we have in San Antonio, especially in the energy sector area, they're in FEMA floodplains. So if we end up raising the structure an extra 2-3 inches, then we have to be able to do the hydraulic analysis, potentially go out there and put in some additional pipes just to make sure we're not going to impact any of the local property owners. We've done that a couple times in the past and it didn't turn out good. So we're very sensitive on keeping that profile right where it needs to be. So what it really comes down to is 3 things, right? We want to try and build something cheap, fast, and durable. And in most cases, I can get you to getting the third one is very difficult. I might be jumping the gun, but I just want to try and give everyone a basic idea on price differential. So what I did is I tried to equate this in how much it would cost for a reclamation process compared to a replacement process using either one of these. So, you can't laser pointer? That one? Yeah, there it is. This top one talks about if we just went in there with the typical cement treatment. So we can go in there pretty cheap. We don't have to try and tear anything out. If the existing material is good, we hit it with cement, we're going to get about $3.50 a square yard. If you look at trying to do a full-blown replacement where you're going to take out 8 inches, you're going to bring in new base, you're going to cement treat that, it gets pretty high, $16 a square yard. But if you do full-depth hot mix, you're looking about $30 a square yard. And then the EET is about $16 a square yard. So in relationship, you take a look at this, you're like, oh my goodness, it's so much more expensive than cement treatment. Why would I want to go this route? Actually, I thought I had a better picture in here. Oh, I didn't. So some of the things that we get concerned about when you go cement treatment is shrinkage cracking. So that's something we're always cognizant of as well, right? When we go out there, we cement treatment, It's going to shrink on us, and even if we micro crack it, those cracks may still end up coming through. So EET or foam nasal, either one, they're really going to try and keep that structure a lot more flexible. It's not going to have those cracks come all the way back up through. So that is a definite benefit of it. The other thing is that it's fast. We can get out there, we can hit a stretch of road, we don't have to worry about hauling off material, we rarely have to worry about trying to find some stockpile location on the side of the road to try and hold any material that's torn out or bring in new material. So there are benefits for it just in the construction aspect alone, that this, just looking at these numbers alone, does not quantify. Oh, there you go. We had very good partners that we were working with in developing the usage of emulsion treated base. And one of the things that has been used around the nation is that they've been able to open it up at the end of the day. So that's another side benefit. We can go in there, hit it with the emulsion, open it up to traffic by the end of the day. We can break down the traffic control so traffic can hit it immediately. So here's a picture of the idea of pretty much what we want to see. In this particular aspect right here, you're not seeing the surface of the emulsion treated base. There was actually a seal coat that was put directly on top just to hold it off, but it looks pretty uniform, you know, it looks really good. Did some digging. The emulsion treated base has actually been used quite a bit around Texas. And this is just kind of a summary to show you projects where we have used it around the state. And there was a research project done by UT El Paso. So they didn't hit too many times with the FWD, but they did hit it with the P-SPA. Similar situation. I mean, we did see that if you go back out there and you hit it with the P-SPA or the FWD after that, there is additional stiffening effects compared to if you go out there and you hit it the same day. But just in general terms, you can see that there is a definite stiffness increase depending on how much emulsion you're putting in, how much cement you're putting in, and what you can try and expect. Hit it with the FWD at the same time. There's a little bit lower correlation there. So if you were going to try and compare this particular section on 479, where it had a seismic modulus of 487 KSI, compare that back to a FWD, we're probably pretty close to that 300 KSI that we're looking at if you did back calculation through FWD. So it's pretty good. You know, that's really darn good. Those when I'm looking at numbers that high, that's not typically something I would actually associate to a cement treated base. So if I'm doing a pavement design and I'm going to use a value of 300 KSI for a EET section, I'm going to be able to thin it up compared to if I did a cement treatment. There's the picture I was looking for. Here's a typical cracking pattern if you do end up going with cement treatment. You know, you get these shrinkage tracks that just come all the way back up through, and this is just a perpetual problem. Water's going to get in there. It's going to start to erode the base. You're going to get pop-outs. So that's one thing that we don't want to continue to have to battle for the maintenance sessions. All right, so I want to go over the most recent one that we did in San Antonio. We did a stretch on SH-85. It's about as far south as you can go in Frio County. This road is just heavily impacted with trucks. 50 to 90% trucks every day. It's unreal. Every time that we were out there on the construction job, there was at least maybe one to two traffic accidents every week because there were just so many trucks through the roof. This is an idea what the road looked like before. It was actually in really good shape until 5 years ago, and then you get these one-load failures where you get a 1 million-pound truck coming through, just destroys the pavement. The road was never built to handle the loads that were this big. So this was a perpetual problem for the maintenance section. They hated this road. This is their worst road. They were dumping all of their money, all their material budget, all the resources into maintaining this one road, which means everything else gets neglected. So they were screaming. They said, "Man, please help us out. We have to fix SH-85. This is a nightmare." So once we initially started to take a look at it, that's where all these terrible boundary conditions came into play, right? We got no right of way. We got 2 lanes, virtually no shoulder. We can't really divert traffic anywhere. If we put in 24-hour traffic control, man, our budget's going to be blown. We had to let it out to an RMC contract as well, so the budget was not as high as we needed it to be, and we could not raise the elevation a significant amount. So we said, all right, let's go ahead and go with an EET product in this particular area. So this is what we had initially. We had 2 to 4 inches of probably seal coat, actually, over 3 to 12 inches of base. Yeah, nice and uniform. Yeah. So what we planned to do is we were going to mill out the top 4 inches of that material, and we were going to go ahead and bring in some additional 4 inches of flex base, and we want to do 8 inches of EET. I say EET, I think the name's changed. You guys know what I'm talking about. And then cover it up with a 2-inch layer of some type D. So we went out there. Initially, man, it was looking good, man, looking all right. And then we ran into some, difficult sections. Just like, it's life, right? Things happen. Oh, man, crap, something happened. So we had to go out there. We had to try and come up with a good solution on what was going on with this road. Was it the emulsion treatment that was going on? Took some cores, and some came out beautiful. I mean, honestly, look at that thing. That thing almost looks like a hot mix core. It looks beautiful. It looks so good. And then we had the not so good where things just really fell apart. The thing that we ended up finding that probably ended up hurting us the most was the varying in that base thickness. 3 to 12 inches. Oh, man. It was coming in and out. And when it got really thin, that's where the problems really started to occur. We started to actually tear up the subgrade that was out there, and the subgrade was a very high PI clay. And the downside with high PI clay and asphalt, man, they don't like each other. So they just create clay balls. You don't let the emulsion do what it's supposed to do. So we went back to our producers, our contractors, to try and come up with a good solution. We went back and we redesigned it, and we tried to come up with some modified options on what we could actually end up doing out in the field. We ended up trying to throw in some additional cement, trying to increase the emulsion content to try and come up with a better road. It worked out pretty good. We finished it up back in summer 2014, and I want to show you a couple videos of how it looks now. I took these videos about 3-4 weeks ago. And this is how it looks right now. It looks really smooth. So we took this video at 10 a.m. on a Friday, so you're really not getting an impact for the truck traffic on this road. But it is through the roof. It is gigantic. It's enormous. It's like I was saying before, this was the biggest nightmare for the maintenance section supervisor. He hated this road. He couldn't get off of it fast enough. Now when you go out there, there's no problems on it. He has not needed to go out there to do a single thing to it. He's able to concentrate on the other roads in his area. It's worked out really, really well for us so far. Let me show you another one. There's another one going the other way. Just show you we actually did something. We did end up doing a lot more detailed investigation, but we were kind of, I know I'm limited on time, but if you guys do want some more information, I'd be more willing to share it with you. We got FWD before construction, during construction, after construction, a couple weeks after construction. We got DCP testing that was done out on the road during construction as well. Cost estimates as well. Similar to the process, I didn't have this in the presentation, but usually what we're looking at is about 2.5% residual of the emulsion being added to the base. So the price or the emulsion content's a little bit low compared to traditional dense graded or hot mix asphalt. We have excellent resources in San Antonio, I'll say that. The emulsion that we used was probably way better than what we have in the spec right now. If you look at the special spec that does exist right now, though, the emulsion, you could probably get away with a CSS1H or an SS1H to actually meet those specification requirements. But we have some pretty good suppliers in our area, and I think they bumped it up a little bit for us. That's all I got. Any questions?
Thank you, guys. Great job. Questions for Stephen and Brett? Anybody?
So the
Question is, did the construction have an effect on
So the The question was, were we worried about the stop and go on some of the rutted areas that existed, like in the picture that was shown before on that picture right there? Yeah, initially it was, right? So even though this was helping us out in the phasing of the job, we still had to have shorter stretches that the contractor could take care of in a day. So we did have 24-hour traffic control set up. So we would have to stop traffic at one end, have a pilot car drive them around. So the traffic was stopping at one end until we could try and bring them around. These trucks are just ginormous, right? So everywhere they were coming to a halt, which is right at the start or end of that individual section, we started to see a little bit of ruts because of all the additional shear forces. And that's where we did start to see some of these areas coming up. At that time, we were concerned. We're like, oh my goodness, is this going to propagate through? Are we going to see this periodic rutting occur everywhere we had to go back in and try and take care of it? Now, in these particular sections, we did have to go out there and do some additional rehabilitation in that individual area. But the good thing is that you don't see it now. It is not there. There's nowhere on that road where that rut or that weakness is showing through on that road yet. So while it was an initial concern, right now, we're doing really well. Any other questions? Okay, thank you all very much.
Are there any places you would not use one of these?
Yeah, he asked if there's anywhere we would not use one of these. If you don't have a good base structure, if you have, kind of like iron ore base or some type of weak base, then high PI clays they may get brought back up into that mixing process. You wouldn't want to use it there. I mean, you need to have somewhat of a good foundation material to work with. If you don't, you need to add probably new base, something to get that full depth base in there, because once you start getting into the subgrade, the asphalt just doesn't like to bond and coat to that higher PI material. Everything we use on State Highway 7, it's got a good thick base layer or hot mix and a good proportion of wrap to base. So that's a good application or a place to use that.
Yeah, just follow up on what Steve was saying. I'm very confident in the mix design and how it's performing out in the field. So as long as I got a good mix design, I'm okay. Now the secondary process is, are we able to create the exact same thing out in the field that we've done in the lab? And that's where the difficulty is. So the only other limitation I would really put it into it for us compared to what we've already done and developed is that if I have a clay that's got a PI of higher than 10, I do not want to utilize this process.
Other questions?